Then part 1 asks you to express shortest distance of P from OX and OY in terms of theta. First thing first, shortest distance from one line to a dot. This being the line and this being the point or dot. The shortest distance will always be perpendicular to this very line. So in this case it's like this. Let's say this is point J, for example. It will be perpendicular, but it will only be perpendicular at one point. So it won't be here, it won't be perpendicular here either, because any other point along here to here will always be longer. Just the same from here to here, always be longer. So let's look at OX for example first. OX being this line, shortest distance to point P will always be perpendicular. In this case, from here to here, perpendicular. Just the same for your physics or scalar vector, right? Or whichever topic it is, perpendicular, always keep it as shortest distance always be perpendicular from line to point. So for this question proper, there's no alternative but by trigonometry Picasso, right? Since we have one length, we have the given angle, and you're asked to find the another length. So in this case, this is the angle, this is your hypotenuse, and you're asked to find opposite. So straight away you have O, you have H, so we can't be, so this only have O and A, so it's not. You have A, you have H, which is not again. So you have O, you have H, so you use so. I'll shift a bit. So a few ways to do it. Let's label this as H first, and label this as L. Maybe for you can use other variables as well. There. So here H should be equals to 4 cosine theta, and how we get that? Sorry, 4 sine theta actually. As we go over here, right? And how do you get that? Sine theta is equals to opposite, which is what you want, right? So let's use H instead. H over hypotenuse, which is 4. So you multiply that over, you get H is equals to 4 sine theta. And here L is equals to, because theta is over here, so it's a bit hard. Instead we could make theta over here, since it's alternate angle, right? Alternate angles, parallel lines. So same again, using 4. This time one is not hypotenuse, no, it's still hypotenuse. And what we're trying to find here will be adjacent. So adjacent we look at car, because adjacent and hypotenuse. L is equals to 4 cosine theta. The derivation is here, again it's not necessary if you are used to it. Adjacent being what you're trying to find, L over hypotenuse, which we know to be 4 as in here. Not here actually. So multiply over, once again L is equals to 4 cosine theta. The real trick is when, since this is your hypotenuse, right? If it's hypotenuse multiplied by cosine theta, it will be on your adjacent side. If it's multiplied by sine theta, it will be, being 4 sine theta, it will be over here, referring to your opposite side. You can get used to it over time through practice. But otherwise, if you are scared, just constantly do this kind of calculation during exams instead. So working wise, it's just this, and this you're working for 11 part 1.